on page 311, we're going to go through a few of these, then we're going to add some other stuff to the notes, then we're going to add on to this assignment. Let me gotta make sure I know which ones I want to go through.
I'm getting too old. I used to be able to walk.
Look at number 5. Number 5 first. On number 5, I'm going to show you a couple of ways to do this. We'll do a few problems, maybe one or two from each section or something, and then the rest of them are yours. On number 5, on this chart, it shows, on this little chart, it shows your confidence levels of 80, 90, 95, and 99. We use 90, 95, and 99 most of the time, but it also shows 80. But I'm going to show you how to find it using the actual standard normal chart also. In case it's not on that little chart, then you can do this. So if I have this, if this is my curve, with these critical values, what we're saying, if it's 80%, that means we want 80% to fall in here. Well, if 80% falls in there, what percentage is in each of these tables?
10 or 10%.
10%. And what we look at then, we want to change that 10% into a decimal, which is just 0.10, and we look up that number on the standard normal charts. So on this chart. So you look on this chart, you're using the chart backwards. And so we look up, and I'd probably be prepared for a quiz coming up like here next week at some point, probably early, over a bunch of stuff. We try to find whatever's closest to 0.1. I'm looking through here if I can see it. Looks like right here it says 0.1003. And that tells us, we go back and use the chart backwards, that tells us our critical value, our z-score, is negative 1.28. We don't really need the negative, we just need the positive answer. So that's our critical value. And if you look down here at the bottom, because 80% is on this little chart, it tells you 1.28. But that's how you use the big chart if it's not on there. So if they say something crazy on a problem, like you want, you're looking at it and you want 30% of the data to be in here. Then that means like 35% here and 35% here. If we got to find those critical values, which they probably, most of the time it won't happen this way, but we got to find those critical values, then we look up, this is a percentage, we look up 0.35 on there to find our critical values. The next one, number 6, isn't on the little chart, so we have to use the other chart backwards. And it says, let's see here, number 6 says 0.85. None of the rest of the 3 are on the little chart. The first one was, the 6, 7, and 8 weren't. So if we're looking at this, that's looks like one of your guys' normal curves.
Sorry.
We want 0.85 in here, or 85% in there. What's left over that's not in the 0.85? About 15%, 0.15. Now remember, divide that by 2. Somebody help me out. What's 0.15 divided by 2?
0.075.
That's the number that we look up on the chart. And it's probably not going to be on here, but we just find what's closest. It looks like we got 0.0749 right there. That's pretty close. So we look it back, that's negative 1.44. And again, we don't need the negative, we just want the z-score, so 1.44. So this critical value would be negative 1.44. This one would be a positive 1.44. But that's the answer to number 6. Jumping down to the next section. Number 9. Not drawing that whole number line or anything. Number 9, they tell us that X bar is 3.8. And our mu is 4.27. These aren't hard. They want us to find, and again, I don't know, I can't tell you when you'll ever actually find this. They want us to find the sampling error. Not the margin of error, but the sampling error. The sampling error, all we do to find the sampling error is you take X bar minus mu. So we just take 3.8 minus 4.27. Somebody help me out, what's 3.8 minus 4.27?
Negative 4.7.
That's not right.
Negative
0.47.
Oh, I forgot to say point.
You said 4.7.
Oh, well, yeah.
You took the point out.
Yeah.
I can't.
Gosh.
So that's our sampling error. Again, I'm not sure when you're ever really going to know the mean of the population and the mean of the sample when we're doing most of this stuff, but that's what sampling error is. 10, 11, and 12 are the same thing, so I'm skipping over those. All you do on each one of those is X bar minus mean, and that's the sampling error. Not 12. 13 says find the margin of error. This is more what we do, all right? So we're trying to find the margin of error, which is E. Speaking of which, probably another symbols test coming up real quick next week also. So we're going to find E. We had a formula. The formula for E was, I gotta remember what it was. The critical value times sigma, standard deviation, over the square root of n. To find the critical value, to find the z-score, we use our chart. On number 13, they say confidence level of 95, so we look right here at the little chart. And for 0.95, 1.96 times, we don't know sigma, but we do know S, so we just put S in the place of sigma right here. And S this time was 5.2, is that right? And our N this time was 30. When you're punching this into your calculator, what I would do, the way I do it on my calculator, is I punch in this part first. 5.2 divided by the square root of 30, it equals, and then just hit times 1.6.
1.96.
Or 1.96, thank you.
1.860.
And go out about 3 places, that's what we usually go out. Again, that's our E, which is our margin of error. What we're going to use that margin of error for is if we're on our number line, we're going to put the mean here, right in the middle. And then to find the other numbers out here, where we want our interval to go to, we're going to take the mean, subtract off the 1.86, the margin of error, to get this number here. So we're going to subtract it, mean X bar minus E, to get this number. and over here, we're gonna add it to get this number. 14, 15, 16, same thing. (17, 18, 19, 20), they want you to match them. When I'm matching them, 17, they say a confidence interval of 0.88. 18 says a confidence interval 0.90. 19 says a confidence interval of 0.95. And 20 says confidence interval of 0.98. You don't have to look all these up. If they're asking you just to match them, make it easy on yourself. Which one of these are we going to be the most confident about?
98.
So what that's telling you is your confidence interval. If you're 98% confident, it's going to be bigger. So looking at those, all I do is I look at the right-hand side. Which one goes out the farthest on the right? A.
Yep.
Goes out to 59.5. That's higher than everything else.
Yep.
So that goes right here. Which one goes out the next farthest?
B, 59.2.
59.2.
Which one goes out the next farthest?
D, 58.9.
And then that leaves C, so I'm guessing C's got to be the answer for number 17 then.
58.8.
Lucas was there. So, what was it that talked to the Vietnamese? The text.
21. On 21, I'm going to show you two different ways to do it. 21, 22, 20, and this is what you're, this isn't just for 21 through 24, this is probably for the rest of the page. You're finding the confidence interval. 21, they give us C equals 0.90, X bar equals 12.3, and S equals 1.5, N equals 50. And again, I forget all the time, but our N needs to be bigger than 30. I don't even usually check it because I think every one of them has been. What we want to do, we want to make a confidence interval for this. If I'm doing this out longhand, do it that way, then I'll show you how to do it on the calculator again. If I'm doing it out longhand, first thing I want to find is I want to find our E. Remember, our E is the critical value times sigma over the square root of n. Our critical value, we look at our C here, which is 90. Go to our chart. For 90, confidence level of 90, 1.645. Our sigma, we don't know sigma, but we do know S, that's 1.5. And our N is 50. So square root of 50. Somebody help me out. 1.5 divided by square root of 50. It equals, and then times that by 1.645.
Times what?
1.645.
0.389.
We can turn this light back on. This light on because I couldn't see her. Say it again.
0.3489.
Is this how it usually is?
0.349, we'll say.
Yeah.
No.
Now, to find what mu has to fall between, for those of you who are still little kids, we're using the alligator mouse here. To find what mu is, all we do on this side, we take x bar minus our E. On this side, we take x bar plus D. X bar is 12.3. Somebody help me out. What's 12.3 minus 0.349?
11.951.
Then on the other side, I can probably do that in my head, that's 12.649, right?
Yep.
Not really all that difficult, doing it out longhand. Just, if you have your calculator, it's easier to do that, because all you gotta do is punch in the numbers on your calculators, and if you have your calculator with you, you might wanna make sure you get it out and know how to do this. You hit the stat button. Under stats, go over to tests. And you go down to the Z interval. Click on it.
Mr. Ebersole, can I go see if my calculator is in the locker room? I couldn't get in there today because he blocks the door.
Once you have that in there, it asks you if you want, what does it say next? What's it say first? Data or stats? Stats, data. We want data. And then it's just gonna ask you to put in stuff down the line. The first thing it asks you to put in is S.
Hold on. Data, it says frequency and list. No. Or is it stats?
You told me that.
Oh, well. I was looking at
So,
it.
so we want stats, not data.
I was looking at it like, that doesn't make sense.
Isaac told me that they were backwards, and
I'm just.
wanted to make me look dumb on the video. So we want stats, and first thing they ask you to put in on stats is S, right? So you put in S, then they ask you to put in X bar, then they ask you to put in N, is that right?
Yeah.
And then they ask you for C, which this time is 0.90, that's our confidence interval. And then it says, it's got calculate down here. And you just click on the calculate. And it's gonna show you something that's in parentheses. And I bet it says 11.951 and 12.649. Is that what it says?
Yeah.
Yep.
That's our confidence interval, just written a different way. And what we're saying with all of this, our sample said that the mean was about 12.3. Well, we know that every sample is going to be different. So the population mean isn't probably going to be 12, or isn't going to be 12.3. But we know that the population mean with a 90% confidence is going to fall between 11.951 and 12.649. So if we do some sample and our sample comes up with a mean of 14.7, we probably messed up somewhere, because that's way outside this range. '22, '23, '24, exact same thing. Now get out the notes from last time. 25 through 28, we'll talk about them here in a minute. I'm going to go back over just a little bit of this just real quick. Remember, your point of estimate, you're estimating what some certain statistic is for the entire population. The one that we're dealing with right now is the mean. We could deal with other ones like standard deviation. We could deal with the variance and so on and so on. But right now we're dealing with just the mean. We're gonna figure out the point of estimates right here. We're gonna figure out some range. And we're gonna say, and you're gonna have to be able to do this, write this out and explain it with 90% confidence. We can say that the mean grade on the next prob and stats test will be between 32.8% and 64.5%. Let's hope not, but that you're going to have to be able to write that out and explain it. It's not hard to write these out and explain it because you're saying the same thing basically every single time. The only thing that's really changing is what we're dealing with. The next prob stats test, that's going to change, and then what your numbers are, what you're saying they fall in between. Level of confidence, again, 90, 95, 99, 80, 90, 95, and 99 are all right here. Those are the ones that we'll deal with most all the time. We just want the positive of that answer, or of what you find on the chart. They're considered critical values, so like if we're doing 90%, then that means 90% of the data is falling in that blue part. And then each of the tails here, this is 5%, that's 5%, we split it up. Sampling error, again, is just x bar minus mu. I have no idea, again, where, because if you know mu, I'm not sure. Margin of error, very important. You didn't write down this formula last time. Key to a whole lot of this chapter. ZC times, that's your critical value that you get off the chart. Your sigma divided by the square root of n. To find your confidence interval, that formula, subtract, you take x bar minus the margin of error on the left, x bar plus the margin of error on the right. If you're using your calculator, then it does all that for you. We just talked about that, what you're saying. That's how we do it on the calculator. So you do stats, test, Z interval. Then we want stats, the data one. If you put into a list, you're just sticking your numbers in and putting them in a list, which I think there is one problem on the homework. Then you use data instead of stats there, and it'll do all the stuff for you. It'll just pull that list over to this and do all the work. All right, this wasn't on the last time. We didn't get to it last time. Very important things. I guarantee there's 4 or 5 problems on the next test that deal with this, and these are real easy as long as you pay attention right now. They give you a confidence interval, 3.29 to 9.62. So they give us the confidence interval this time. They want us to find the margin of error, and the sample mean. All you do to find the margin of error, and I'm going to write down what you do first, and then we'll actually do it. all you do to find the margin of error is, gotta remember here real quick, subtract your two numbers here. So subtract your, let's say limits, lower limit and a higher limit, and divide the answer by 2. To find the sample mean, it's almost the same thing, except, and how would we find the number? If you were looking for the number that's right in the middle of all that, that's where the mean's at, what would you do? Instead of subtracting the 2 limits, what would you do with it? Add them in, divide by 2. So add the limits and divide by 2. Several problems on the homework that ask you to do this. Nothing hard about it, just knowing the math. Now when I subtract them, I don't want to subtract them in the order they're in, because what's that going to give me?
It's gonna be the middle.
A negative, and I don't want to deal with a negative. So 9.62 minus 3.28 divided by 2. And if do it on your calculator real quick, and if somebody tells me that the answer is 7 point something, I'm going to tell them they're wrong.
So it's 3.17.
That don't sound right. Oh, no, that might be right. My fault. What is it?
3.17.
I was thinking
I
of-
was right.
I was thinking of the mean. Same thing on this one.
Wait a second, I didn't get 3.17.
Didn't get that?
Yeah, 6.34.
Did you do it all in one?
Oh, and then he divided it. I forgot to do that. I thought he was just subtracting. 3.17. Yeah.
3.17?
Yeah.
Now, the main thing here, with both of these, you've got to make sure, do the top, then hit equals before you do the division. Alright? Because if you just punch all in your calculator just like this, it's going to mess it up. Or you could put parentheses around this, but that's just extra buttons to hit on the calculator. Now, with this one, as soon as I look at this, I look at 9 and 3. What's halfway between 9 and 3? 6. So I know my answer should be somewhere close to 6. What's it come out to be? 6.45. That's our mean of our sample. That is our margin of error. We got a great big huge margin of error this time because I just made up 2 crazy numbers and threw them in there. But if they give you the confidence interval, that's all you're doing. You're doing those 2 things. Find the margin of error, find the mean. Sample size. As we get bigger sample sizes, so if our sample size is 30, and then somebody else does the same thing that we're doing, but their sample size is of 100, which one's going to give us the better data?
30.
Or 30.
100.
The bigger the sample,
Oh, more out.
the more accurate you're going to be, right? So we'd always like our sample size to be big. Also, the same idea with the confidence levels. Not being 90% confident means that you're going to have a small interval. Being 99% confident means you're going to have a bigger interval. Now, 99% isn't necessarily better than 90%. A lot of the political stuff that you see, they use 99% because what's that do to their, what they can say?
Makes it more accurate.
Makes it real wide.
So they can mess up more.
Right, they can mess up more and say, oh no, we were right. It fell in that range. So when you see stuff on TV and you'll see stuff like, they'll say, so-and-so is in the, has 45% of the votes. And then they'll say this, plus or minus 7%. What that's telling you exactly what we're finding here. That's telling you that interval that it could be. So 45 minus 7 is 38%. 45 plus 7 is 52%. So they're saying that the sample that they did is 45, or it says that they have 45% of the vote. That could go all the way down to 38%, or it could go all the way up to 52%. So when they say something like, I hear on the news or on some of you hear on one newscast this and one newscast this. One will say, Joe Biden's approval rating right now is 62%. Then on another newscast, you'll hear Biden's approval rating is 78%. Well, which one's right? They're probably both correct.
Depending on who you ask, too.
What happens here is what's going on here is, let's see, his approval rating's probably like 70%. And one newscast knew that the margin of error was 8%. Well, going down this way, that's 62%. So they're using the low end, and then the other one is using the high end. So you can make it say whatever you want. All right, a sample size. And we didn't have this last time, and this is important. This is part of what's going to get added on today. This formula is how to find the minimum sample size that makes your numbers worth anything. If you don't have at least the minimum sample size, then all your statistics and stuff are just worthless. And when you watch stuff like back when Trump was running against Clinton, this is what those people didn't worry about. The margin of error and the minimum sample size. So they were doing samples of 20 people when their minimum sample size probably should have been quite a bit higher than that. So they're saying, oh yeah, we stood outside here and we did 20 people and 12 of them said that they were for Clinton. Well, that might have been those 20, but that didn't give them a good sample. And they needed to know what's the minimum sample size that we can use to actually make our data worthwhile. And this is the formula for that. So your critical value there again, that just comes from your charts. Your sigma, you're probably normally going to put S in its place. Then the margin of error, that comes from the formula sorry, I couldn't remember it for a second. When they're asking you to find the minimum sample size, most of the time they're going to tell you the margin of error. A lot of times if we don't know the margin of error, or we haven't found it, a lot of times a lot of these surveys and different things just use like 1 as a margin of error or 2 as a margin of error, just to make it easy. And then that sort of gives them a ballpark of how many items do they actually need in their sample. Because if you're starting off, if we're getting ready to go out and do some kind of survey. We don't know what the margin of error is yet because we haven't done the sample yet, so we're sort of stuck. But we could throw something in there and say, all right, we want our margin of error to be about 2. And if that's our margin of error, then we can figure out, all right, we need to do our sample of at least 78 people or whatever it comes out to be. Alright, did this. So on this one, when we did this, minimum number that we should use, we used, I think it was like, I can't remember what this one had on it now, what N was for this one. But the minimum number that should have been used is about 96. Same idea with this as with some of the other stuff we've done in the past. You're not going to go out and survey 96.04 people. So you should do at least how many?
100.
All right, probably round that up to 100, but we'll say at least
97.
97. Always round it up. Always go up to the next number. A lot of the problems on the homework, we'll say, do something at like 90% and 95%. They'll say do them both. If you're punching this stuff into your calculator, don't punch it in twice. You punch it into the calculator once, then you can use the back button and go back to it and just punch into whatever's changed. This is what's added to it. This is from last time. You want to do a few of these together, we can. No? You're just going to do them?
Yeah.
And be ready for a quiz next time?
Oh man.